All right. So, welcome to our ultimate box sorting bond project for IC 589. I'm Dennis Harrison, and we had a pretty interesting project. It was a very large scope initially. Sort of as shown here, this is what we wanted to start out with. And there's going to be a sort of like multi-pronged factory floor that would use height data along with weight data and vision sensor to like sort out boxes or different metals or whatnot. But since we had a time constraint, we kind of limited the scope. It's to what we had here. Just a very simple like overview of everything that we did in the course. So it kind of allowed us to kind of showcase everything design. So first off, we learned about ladder logic. This was very new to me, coming from ECE. So we learned about just kind of going through the process of taking in sensor data from our factory floor and inputting it into CCW. And as it goes through here, it counts up the timers based on what boxes go where. And it's sort of this like governing force for the whole factory floor. And it's the backbone for pretty much everything that we did. But it feeds pretty nicely into the other portions of our project, specifically with MQTT, our cloud services, and finally the AI design. So this is done for all that. We have a publishing system, a publisher subscriber sort of architecture that is reading the data from our factory floor, and it's taking the sensor values and the count of each box based on what box goes where. So like if it passes by this passive sensor, it'll count up a counter value here. And then we have a live feed for action, which we coupled with our AI program up with Tripium set. You can see that the number of detections and the detection coordinates of the boxes that are seen in the scene are updated in real time. We were having, it looks like it's working kind of now. Yeah. So we were having issues with the boxes and their timing with the simulation. We think that the computational load on our computers, which are kind of weak computers, it's not any. So we were saying that like if we had more time or if we had a different computer, we can maybe set this up on a different environment. But for the scope of this class, it works.
So the goal is to sort by weight?
Just sort by
height. Okay.
Right.
Yeah. So my complicated scene was to take into all of those considerations. So basically, Factory.io had this pre-made tool, and you could have a digital configuration of a light beam array. And based off of which light beams the boxes hit was the dependent variable on which way you go.
And that's what we're using.
So that's kind of like, I don't want to go into full detail of the ladder logic, but it's like if the bottom light was hit and the second the bottom was hit, it'll go straight. If the bottom three were hit, and then it'll go left. If it were the bottom four would go right. That's basically the ultimate determinant of that. I had to do a lot of experimentation with the scale weights and especially kiting, but it would detect the weight. So let's say the predetermined was still straight, the palletizing box, it would weigh between 2.0 to 2.6. And based off of if it was at a certain range, then it would go either left, straight, or right. And then the vision sensor would also work with the AI implementation. So if you wanted to, you could do blue or green or metal, and you would count the number of times a blue box or green box metal bonds would actually go to some. So that was our ideal and full one.
And we had the scope, like Harrison did a really good job of setting up the factory floor and going through the PLC ladder logic. But we got caught up in other classes, tried to limit the scope, but also contain all the data that we.
Yeah, I would have to make this. This is only like one or two cases. And I'd have to copy and paste and change all of that based off of it. I actually started doing it, but
something that we were mentioning earlier, but didn't account for fully, was that the timing between the simulation and the PLC commands wasn't instant. So that delay sort of started to stack up, and it showed.
That's why it's causing an overflow. Like ideally in our report, we're going to say that in an ideal situation, the sensors are going to be instantaneous. But because sensors are never going to be instantaneous, like we can in the future make like an accountability so you could test like out like another possibility I was making those causing a sensor for it to read and give it time to do its output and then give its idea to do its output. But like I said, or like we said before, the simulation, even when I tried to implement it, wasn't working fully.
Yeah. So it's just a consideration. And if we simulated on a big computer or set it up in a different environment, it might work better. But the controls work. It does sort the boxes based on height. So we felt like that was sufficient and kind of moved on with our project. It gets summed up in our overflow detection, which was out of be and to have this sort of AI agent constantly watching factory floor and being able to tell you, okay, is there an overflow occurring? Which we have here saying like, if there's 4 boxes lined up, then this should switch to true, and you can see the number of detections and the detection coordinates with a given timestamp. So maybe if someone was on a factory floor, they can see when this happened. So make some predictions about that. But yeah, it stacks up, the count goes up, and we pause it. The detection is 4, overflow flips to true, and then there are also coordinates to the boxes, so more information you could do with that. And sort of the last connecting factor is our app, which allows us to query data from the factory floor, and then it gives us a nice little plot along with the table. Ignore this is from last night, but it goes through our PostgreSQL database and then counts up the boxes based off of teams and factory floor. So yeah, I really enjoyed the semester. Is there anything? Yes.
I just had a great time trying to practice with this and nothing different things. I feel like it's my bread and butter. So I'm probably going to continue this after the class and show it to company.
And we got it, but yeah, it was really. We're both from ECE, so it was very sort of eye opening to see what IIT majors go through and what this kind of engineering design goes. But yeah, as you can see, just to kind of again point out our error that we were dealing with. So when it gets read in to the sensor, the reaction on the palette changer of the directional sensor, let's go right what that's called, omnidirectional palette sorter. Yeah, that it doesn't react perfectly, and sometimes it reacts faster than that. Other times, and we think that has to do with like computational about anything like it.
And obviously, if you have more variables, because it comes equal power to make sure that it counts for everything.
Yeah.
Because when I tried to add more variables and just slow down the flow, then you could barely see the output. Some of that.
You'd scroll down and it would
glitch up like, wait, what is this?
But yeah, we had a really good time. So,
thank you, Matt.